Hello, everyone. I'm Hongyi Wen from Cornell Tech. I'm glad to be here to present our work on exploring recommendations under user-controlled data filtering. This is a joint work with my collaborators Longqi, Michael Sobolev, and our advisor Deborah Estrin. Okay, so the classical collaborative filtering framework assumes central control of service providers over user-generated data. And under such a framework, recommendation systems are mostly built upon the complete view of user historical records. However, with increasing data privacy concerns and personal data protection regulations like GDPR, user has been granted privileges to selectively share the data with the user. For example, on Google, users are allowed to delete their service history, for example, like search history, location history, either by time or by keywords. Another example is on Facebook. Users are allowed to delete all of their Facebook data from their platform. So this poses a challenge to the existing design of recommendation algorithms as they need to be robust to such ad hoc user data manipulations. So previous work has looked into using different data modification techniques to protect user privacy. For example, by adding ratings to obfuscate sensitive information such as user gender. But user-driven data filtering techniques, such as the removal of outdated historical data, has not yet been explored. So in this work, we take an initial step to look into how recommendation performance will be affected by a particular scenario, that is, users choose to share only their most recent end days of data. We conducted an offline evaluation using the movie lens 20 million dataset. We simulated two scenarios. Well, in the first one, we simulated the time-sensitive filtering. We control two variables. The first, P, represents the percentage of users who choose to filter their data. You can think of it as the percentage of users who are very sensitive about their information being shared with the service providers. And if P equals to 0.5, meaning 1/4 of the users on the platform will be setting this kind of privacy controls and only share a particular number of data. And we control another variable N, which represents the time span of the data these users share with the service providers. For the rest of the users on this platform, they will by default share their complete historical records. And the other setting we simulated is the non-filtering scenario, where all users on the platform will by default share all of their historical records, which is the current case. So under these two scenarios, we trained our recommenders on these two scenarios by using three commonly used collaborative filtering-based recommenders. And we test the performance on the same held-out test set to compare the performance change under different P&N settings versus the non-filtering baseline. So we use two evaluation metrics, hit ratio at 10 or recall at 10, and also NDCG. So here's our findings. Due to the space limit here, I'm going to only show some representative results, but please refer to our paper for more details and comprehensive analysis. So here, this is showing the high-level performance change on the population level. So the y-axis shows the relative performance change under these different P&N settings as compared to the non-filtering baseline. So a negative number, meaning the performance will be decreased. So if you look at vertically, different colors represents different percentage of P. So a larger P clearly affects the performance more. So meaning that more users choose to filter their data will have a higher impact on the performance received by the population level. If you look at the x-axis, which represents the time span of the data shared by those users who choose to filter, the performance will be increasing as they share more data. But an interesting observation is that the best performance was achieved around 60 days instead of using the whole training data of 1 year user history. This is somehow interesting because this suggests we don't need all of user historical records to train a decent recommendation system. But on these particular settings, of movie recommendations, we only need around 60 days or 90 days of data to get a decent performance for recommending movies. So a natural question to ask is whether the baseline we used in the previous experiment is actually a strong baseline, because normally we would think that if we incorporate more user historical record, such as 5 years of user histories instead of 1 year, this might getting us better performance. So here we trained our recommenders on different varying lengths of histories from 1 year to 5 years in multiples of 6 months. And we show that actually training on the 1 year data set getting us better performance as compared to using more out-of-dated user histories. So this further confirms that the baseline we used in the previous experiment is actually a strong baseline. And ideally, if we do experiment for different ends from 1 day and to the 5 years, we could see some trends that the performance first decrease and then keep increasing to the baseline scenario where we were using all the data, and then drops again when we incorporate more user histories. So this kind of suggests under a specific scenario, service provider might want to choose a particular end in terms of using the minimum amount of user data to do recommendations. We also look at the disaggregated performance for different group of users on the platform. So we identified 3 groups of users. For the first one, which are the users who filter their data. And the second group of users are those whose data records are not modified. And the third group of users are the cold start users who don't have any previous history on this platform. So I will just give the high-level results that we see from this analysis. So for the filtered users, their performance will be negatively affected when they share only a few amount of days of data. And generally, when they share more data, they will get better performance. And at around 60 days, they will receive the performance as comparable to when they share all of their historical records. And for the users who don't filter out any data, they might have concerns that whether if I share all of my data, whether my performance will be affected by the fact that other users choose to share less of their data. And the good news for them is that this actually is not the case. So their performance are pretty stable, even that other users on the platform choose to filter their data. And the third group, for the cold start users, their performance actually is algorithm dependent. So we found that for PMF and CML, the performance is rather stable as compared to non-filtering at all. But under BPR, their performance could be highly positively or negatively affected by the fact that other users choose to filter their data. So this also implicates that in the future choice of recommendation algorithms for service providers, they will need to concern about this for this group of users, whether the recommendation algorithm you choose is sensitive to the fact that other users will be actively control what they share with the service providers. So, to sum up, our experimental results shows that it is possible for users to selectively share the data without suffering from their performance decrease. And we don't always need the full user historical records to do recommendations. Moreover, we can, future work, we can look at models that incorporate temporal information and also contextual information that raises research questions beyond how users are going to share the data beyond just clicks and readings. Last but not the least, in the real world, actually, the user data sharing patterns are much more complex than we simulated using just 2 parameters, P and N. So we want to apply this approach to real-world cases that have other data control mechanisms, for example, sharing by content, sharing by locations, instead of just this user item per item pairs of interactions. So this is pretty much it, and I'm happy to take questions. And our code are released on GitHub. Feel free to reproduce our results and do check out the paper as well. Thank you.
Any question? Okay, so let me ask you one question. You said that you actually tried to look at the effect of the last days of recommendations, but there are many other things that could affect the quality, like the activity of the number of items that the user actually looked at, or the domains. Some of the domains are very affected by the time, and some of the domains are not affected. And is it really like a realistic scenario that the user would say, I don't want the last few days to be included, or is it more realistic to say that user would just choose specific items that he wouldn't like the system to see?
It's a good question. So this question is more about whether the sharing most recent end days of data is a realistic or useful scenario for the users who wants to control their information. So I think on some service platforms, the users right now have the option to choose how long of the data will be stored on the platform or the database. And so this is like the inspired why we use this particular sharing most end days of data scenario. But in real world, there are many other confounding factors, for example, seasonal effect that actually requires you to store more data because you want to also examine what will happen to a particular event after particular events like World Cup every 4 years or like during that period of time. So this raises questions that maybe the time filtering, but based on the most recent end days, is not enough. We might also check like the particular time window around that event to do this kind of selective sharing. And also, we have other keyword-based or content-based sharing mechanisms that also should be investigated in the future work.
Okay, thank you. So let's thank the speaker. Thank you.